So today we will derive the equation about the homogeneous function. It is called Euler's equation on homogeneous function. So Euler's equation on homogeneous function. So what is a homogeneous function? Let's first understand very briefly that the homogeneous function is in the form of phi equals to x raised to the power n times function of y over x. Here x and y are the variables. So let's say this is the homogeneous function and let's say this is the equation 1. Let's derive the equation 1 partially with respect to x and y independently. Okay, so firstly, partial phi over partial x is, so this is the product function. So let's apply the product rule of the differentiation. And here with respect to x, we are differentiating it. So x is a variable and the rest of the variables are the constant. So only two variables are here. So x is one of them and y is one of them. So we are going to treat y as a constant. So this is in the product function. As we know, if y equals to uv, so differentiation of y is going to be first function, differentiation of the second function, plus second function, differentiation of the second function. This is the rule we are going to apply, and this is what we learned in high school. We already have learned this in the high school. So I'm just reminding this rule. So let's apply the product rule. So first function, let's say sorry, okay, so first function, differentiation of the second function, plus second function, differentiation of the first function. So how we are going to do it, differentiate the function of y over x? So this is f prime y over x, and we also gonna differentiate inside. So that would be in terms of x, right? So y over x squared. So how is that possible? So 1 over x means x raised to the power minus n, and if we differentiate this would become minus 1 times x raised to the power minus 2. So now that's the minus 1 over x raised to the power 2, right? So that's what we did here. So we are gonna put minus sign here. Now let's do the general solution. Now n x raised to the power n minus 1 function of y over x minus y x raised to the power n minus 2 f prime of y over x. So this is what we got when we partially differentiated the equation 1. So let's partially differentiate with respect to y. So now here x is not a variable, it's a constant, so we're gonna write as it is. So what we are gonna differentiate is just this function, thus this one. Okay, so now this is the variable. Now differentiate it. So here the x is a constant, so y over x as it is. So the differentiation of y is just 1. So now what's our answer here? That's x raised to the power n function f prime of y over x. So now this x is going to be 1. So if we put this on the numerator, it's minus 1, right? So let's say this is the equation 2, this is 3. So by Euler's equation, what is Euler's equation? So by Euler's equation, we know x partial phi over partial x plus y partial phi over partial y equals to n times phi, right? So that's the Euler's equation. So let's do the LHS, right hand side equation. X partial phi over partial x plus y partial phi over partial y. We already have found partial x or partial phi over partial x. What's that? From here, partial phi over partial x is n times x raised to the power minus n minus 1 function of y over x minus y x raised to the power n minus 2 f prime of y over x. So that's the partial phi over partial x. So now the second term is y times, let's put a big bracket, really big bracket. So x raised to the power n minus 1 f prime of y over x. So that's our partial differentiation with the respect to x and y. So let's solve it. So when we multiply this x inside, n times x raised to the power n function of y over x. So now also multiply this x here. So minus y x raised to the power n minus 1 f prime of y over x plus y x raised to the power n minus 1 f prime of y over x. So now this term and these two terms, they are equal, but they have negative sign, so they are going to cancel each other out. So what's left and remained is n times x raised to the power n function of y over x. We know this term is a homogeneous function, so n times phi is what we solved here, right? So that's what we found. So that's the Euler's equation on homogeneous function. So what's the Euler's equation on homogeneous function? That's x partial phi over partial y x plus y partial phi over partial y equals to phi n times phi. So this is our Euler's equation on homogeneous functions. So in the next video, we are going to learn how to solve the equations using the Euler's equation on the homogeneous function. So I hope you understand it. Bye bye, Tara. See you on the next video.